So pie charts are kind of the practical opposite of a bar chart. Where bar charts are good for showing trends over time, pie charts show the situation at a specific point in time. These charts, for example, show the distribution of several different types of bias at the moment the researcher did the analysis. And you can see that these charts have several of the same components as our bar charts. For example, they have titles, right? And they have some kind of legend telling you what the colors represent. And it's also common to see the data values or their percentages outside of the slices, like you have on this chart here on the right. Now, sometimes you'll see something a little unusual in the percentages. If you add these up, the total comes out to just 99% rather than 100. Now, this can happen, right? It can happen sometimes due to rounding error. For example, suppose there was exactly one person in each of these categories, right? And then each section would be 1/3, which is 0.333, which is equivalent to 33.3%, or you could round it down, right? You got to round it at some point. You could round this down to 33%, and because they're all the same, they're all going to get rounded down. And that's what's going to cause you to kind of, in the aggregate, it's going to cause you to lose that 1% that makes it total out to 99 rather than 100. So that's okay, right? If it comes to 99, you know, you're in good shape. Any further than that, 98, okay, then, you know, I would start to be concerned. All right, so there is one other potential issue you can run into with pie charts. They are dependent on your being able to distinguish between the colors. And I ran into a problem just like this once when I was putting together a test. I printed out a page with a pie chart and didn't realize that when it converted to grayscale, several of the colors became indistinguishable. So the students looking at it weren't able to tell which group belonged to managers, which group belonged to directors. Obviously not an issue here, the percentages are the same. But they weren't on the chart on the test, right? So if the numbers are different, that could be an issue. Color blindness can cause a similar problem. Roughly 5 to 8% of the male population and around 1% of women suffer from that condition. So in a company with 50 men and 50 women, fairly small corporation, there's going to be between 6 and 9 people who have this condition and aren't going to be able to distinguish between certain colors. So the rule here, and this is really an ADA, Americans with Disabilities Act compliance rule. The rule is always just to be very careful when you're using color. The preference is if you use color in a way that really means something, like it does in this chart, for example, the preference is that you would also use some kind of secondary way that doesn't use color to indicate the same information, right? That way people who have that particular disability are still going to be able to make sense of the report. Okay, so that's pie charts. So we've got several charts now. We've got bar charts and their variants. We've got pie charts. In the next lecture, we're going to talk about we're going to do two different kinds of ones. We're going to talk about frequency, what is called frequency polygons, what I would usually refer to as a line chart, and a second type called a scatter plot.